Today, I'm going to present on crabs versus gophers. Now, what is this all about? Well, let's back up a little bit. What's the cardinal rule in software engineering? Shit happens. Systems are brittle, and programmers are stupid. Now, a lot of us, generally, when things go down, we like to blame the system. However, blaming the system is a lot like farting and then blaming the dog. A, no one believes you. B, the room still stinks. So, what are you going to do? Well, in the 1970s and 1980s, a telecom provider by the name of Ericsson came up with a very resilient solution. Some inspiration. So the idea here is that they said, okay, systems go down, packets get lost, telecoms are brittle, and so we need those packets to be delivered. So what happens when they don't get delivered properly? Well, we'll just have an actor model, okay? We're going to have all these different processes isolated on their own, and then we're going to have a supervision tree. So when something goes bad, it crashes, and then it restarts. So they came up with this language, Erlang. It looked really ugly. So another engineer came up with a language, Elixir, which is basically meant to take the resilience of Erlang with the syntax of Ruby, right? Now, they merged this with the Open Telecom platform, also known as BeamVM, and for a long time became the holy grail of reliable application development. However, what's wrong about this? Well, there's a couple things that are wrong, right? One, look at the performance. In terms of memory footprint, it's one of the largest. In terms of execution speed, it's one of the slowest, right? Number two, it's dynamically typed. Well, when you're trying to maintain a large code base with lots of complicated business logic, that's a recipe for disaster. Additionally, people started taking and a packet gets dropped, right? You probably want that packet to be redelivered, right? Now let's say that you're sending a $100,000 payment for like a mortgage escrow, right? And that mortgage escrow gets dropped. The wire hits the clearinghouse, but a record doesn't get recorded in the database, so it's recorded as crashed, and it tries again. Well, let's say there's a whole database outage, so it keeps trying again and again and again. Next thing you know, you've wired millions of dollars, right? Not great, right? So instead of this quote, if at first you don't succeed, try again, I prefer this one. So before I tell the quote that I want again, just remember, systems are brittle, but also programmers are stupid. That's the other thing that Elixir doesn't take into account. Sometimes programs just crash, not because the system went down, but because the program is wrong. And because the program is wrong, because the program is wrong, the crash will happen again and again and again and again, right? So I prefer this quote, only the paranoid survive, right? And if you're not paranoid, you should have a compiler that is, right? Now, I'm goth on the inside. Like, when I code, this is me. So I work at Haven. Now, Haven, we're a financial services company. That means there's zero margin for error, right? So when something is unreliable, our head of product coined a phrase. When in doubt, crab it out. Rewrite it in Rust. So with that being said, I'm going to do a little bit of a demo. I'm going to write some code in Rust, and then I'm going to show you how code will fail in Go. And because of that, I'm going to show you then how Rust prevents that failure. So let's take a look. I'm going to start a new project. And I'm going to call this project talk. Okay. Now, we're going to open up the code in here. Okay, cool. Now I'm going to turn off this buggy Copilot because I don't like GitHub Copilot. And I can't even, yeah, here, let's see if I can disable it for this workspace. Okay, cool. Now, here we go. Now, because I'm ghetto, that's right, my family's from the mean streets of Shaker Heights, Ohio, I'm also going to put another file in here, a Go file in the same project. A little bit, yeah. Can I? Okay, is this better? Or zoom out? Do you want me to zoom out or zoom in? Okay. Okay, is this good? That's what she said. So, okay. Let's see. Okay, so we're going to start with Go. And I'm going to write our main function in Go. I told Copilot to turn off. Okay, there we go. Okay, and so I'm going to show you guys how race conditions can happen in Go very, very easily. So I'm going to start by defining a struct now, shared value. And we're going to have a value, and it's going to be string. Okay, so what we're going to do is I'm going to essentially initialize a shared value, and it's going to have value hello. So now we're going to have a function, and this function is going to modify the value to say goodbye. Okay. So now here's where the problem comes. So if we run this code, and then we have a sleep statement here. Here. And we were to do something along the lines of, like 1 second. Sorry, yeah. And then we print out val. We'll see what happens. Okay, so you'll see it's a race condition, right? Because what happened was we initialized it, this thread ran, and it doesn't, and it modified it, to say goodbye. However, if this thread is a little slow, right, then we're going to have a race condition like this. Hello, right? So depending on how long things take, it's unreliable. So let's take a look, and let me show you how Rust prevents that. Okay, so I'm going to define a struct here called shared value. And we're going to name val, and it's going to be called string. Okay, so now I'm going to initialize it in the same way. I'm going to, let's see what happens now. I'm going to call as a parallel process, thread.spawn. And what we're going to do here is we're going to mutate the value. And we're going to call it goodbye. Now, This is all fine because we don't access shared afterwards, right? But if I wanted to, that's where we start to have a problem. So the value was moved into the thread. Now the thread owns that value. We can't modify it, right? Now, that's pretty powerful, but you might say with Go, hey, just use you're doing it wrong. You should use a CSP, a communicating sequential process, right? Well, channels can still be a problem. First, though, let me show you how you would do this the correct way in Go. So the correct way you do this in Go is in Rust it requires you to wrap it in a mutex, which is what you should be doing. So first, I create what's called an atomic reference counter, which keeps track of how many references there are. And then inside here, I create a mutex. Okay. So now what I have to do is I'll grab this mutex. What I'll do is I'm going to create a copy, which is another reference to this, to pass into the closure. So I do tshared, for example, the thread shared value, and I define this as shared.clone. So now inside here, what I do here is I need to grab the mutex lock. Now I can modify it. Now here, I grab the mutex lock, unwrap it, and grab the value. And everybody, let's see. What? Oh. Yep, there you go. Thank you. So there you go. Now everything's happy. It's enforced at the compiler level that we use a mutex to share everything, right? And the problem with Go is even if we did define this as a channel, for example, if I add a function right here called, initialize shared, and we accepted in, a channel like, that would return something like shared value right here, we can do, something like this, right? We can take the channel, pipe in a new instantiation of shared. Then we can actually just go ahead right after this, and we can modify shared value. We can modify, so here, we can send the reference, and then we would be able to modify the reference right here. We still get that race condition, even if we use channels. Now, let's see what happens when we try to do this in Rust. So in Rust, what a channel is called is a multiple, is an MPSC, multiple producer, single consumer. And so in an instantiated channel, I'm going to cast this as, a shared value. And then, excuse me, this is the wrong way to do it. And we need to also, this is the problem with zooming in so much, we need to define it as arc of mutex. There. So here's our channel, right? Now, if we were to grab immutable, if we were to take our, you know, our transmitter here and send shared, it's not going to work because it's going to, or it's not going to work because it's going to, or even here, it won't work because, again, ownership rules prevent you from transmitting things without a lock. So what you would have to do is you would have to clone it, and then you have to, and then you would be able to take this clone, and you have to, again, synchronize your mutex for accessing it, right? You would not be able to just pass in this. If we do, watch what happens. So I have to go and change my type here to only allow a shared value. And oh, right. Yes, I'm sorry. I screwed up my fish syntax. So, oh yeah. There we go. Okay, so if we were to try to pass that in, again, it's not going to work. So ownership rules prevent you essentially from making all of these very easy mistakes that you can make in Go, right? Okay, let me show you one more example while we have enough time. So let's say I have a function that, you know, is called divide2, right? Takes in, you know, a number, which is an integer, and returns an integer, right? So now we want to be able to essentially return nil because we want to be able to, if the number is not divisible by 2, we don't return a result. So what we do is we check if I divided by 2 equals 0, then we return I divided by 2. Or we would have to define it something like this. Result, and then return result. Otherwise, we return nil. Okay, cool. So what happens when we do this? So we'll run main, and I'm going to go and comment this out. So we'll format here what happens when we call divide2 by, I don't know, 10, right? So if we ran, okay, we need to dereference the pointer. Boom. All right, 5. That's great. So return 9. Let's see what happens. Oh, nil pointer exception. Okay. Now let's see what Rust does. Okay, so with Rust, I'm going to implement a function called divide by 2. We're going to take in, you know, a number. We're going to, the number we're going to take in is and so what we're going to return is an option of a number, right? So then we're going to say if I%2 equals 0, then we'll return I divided by, we'll return sum I divided by 2. Otherwise, we'll return none. Okay, cool. Easy enough. Now, let's use this function in the same way we used it with Go, and let's see what happens. Okay, so we try to do divide 2, and we're passing 10. What's the problem? Oh no, we can't just display an option. Okay, so what I'm going to do here is I'm going to define a result like this. So I'm going to say let result equals the match of, divide 2 of 10, right? If we get sum of a number, then we'll just return the result. And then there we go. Good to go, right? I'm getting an error. How do I do this? Oh my gosh, the compiler told me I didn't handle the none type. Okay, let's see. So maybe I'll just return 0 for this. Okay, now it works. Now we can print the result. So this is an example of how the Go compiler how the Rust compiler forces you to handle the errors that you don't expect. So, there's other types of error handling too that you can do. Yes, Warren.
So presumably, I mean, it's a little asymmetrical in the sense that divide by 2 in Rust returns like an option integer as opposed to the Go one just returns like a int. Point presumably, if you just returned an I64 there, it wouldn't compile at all.
Correct. So I mean, if I tried to, I mean,
right. Yeah, you're just not allowed to.
Yeah.
Like, the main thing is like there's no nil in Rust. You can't even, it's like a language construct. You use unsafe Rust, you can, but with regular safe Rust, there's like no way to like test this null dereferencing. Right. It's like not linguistically possible.
Yeah. So, I mean, I can go on and on and on. There's a lot of good stuff. There's the error type, which is results, kind of the same as some or none, requires you to handle okay or error. And if you don't handle error, you get the same problem. It allows you to put the question mark. So if you return a result and you get a result, you can put the question mark and then it'll just propagate the error up if it returns an error. Otherwise, it'll unwrap it. None does the same thing, by the way. Option does the same thing. If you have a function that returns option, and then you yourself call something that returns option, you can put the question mark. It'll just assign the sum value to that function and continue down. Or if you have the none value, it just terminates the function and returns none, right? There's an enum type, which by the way, Go still doesn't have after 15 years of development, right? You can take an enum, have 5 types defined on that enum using this hack called iota that they use, and then you can just pass in 72 to that enum value, and who the fuck knows what's going to happen with that program. I'm sorry. Go's just not it, right? So you have these, people saying, okay, Go is performant, Go is fast, Go is concurrency safe. Well, not really. Especially when you take the fact that the garbage collector thread is also running in the background. You can't even use Go for real-time applications. You can't use Go for device drivers. You can't use it for audio encoding or decoders. You cannot use it for medical devices. You cannot use it for anything that requires real time, because at any point in time, your program will freeze and the garbage collector will come, right? And it's not even safe. So it's garbage collected and unsafe. Now, on the other hand, Rust does not have a garbage collector and it's completely safe. How? Well, it goes back to the ownership model, right? So this mutex that we have here, it's very interesting because one of the things you'll notice I never called unlock. Isn't that a problem? Isn't that a deadlock? Well, when something takes ownership of something in Rust, then that thing will automatically drop it at the end of its scope. And drop can be overridden. So a mutex lock is automatically dropped when you hit here. And when it's dropped, the mutex is unlocked. So 80% of the time, deadlocks cannot happen, right? So memory leaks really don't happen. The only way you can really get a memory leak is a circularly linked data structure, which is pretty like intentional. Other than that, memory leaks don't happen. So I don't know where to stop. I mean, I can talk about this for hours and hours and hours of how Rust solves the holy trinity of software engineering. For the longest time, we've wanted to write applications that are fast, that are concurrent, and that are safe. For the longest of times, we've only been allowed to choose two. Now with Rust, you can choose all three. So again, when in doubt, crab it out. Rewrite it in Rust.
So I'm a huge Rust fan, but just to play devil's advocate, in Go, why not just bring over the result type, bring over the option type, and just try and bring as many more type-safe secure mechanisms like into Go with Go's existing types of stuff?
I mean, you can do that, and it's
instead of the canonical like return error, like as a value, you try to make a more proper result type in Go and use that instead.
right. I mean, you still have to remember to handle the error type, right? So I mean, you can do it in a safer way, but a lot of times with Go, you're returning like references anyway, right? And those references can always be nil. Also, a chain is only as strong as its weakest link, right? Maybe the types you're using can be safe in your code, but you're still going to use libraries. And every time you call a library, you're still always going to have to remember that pesky if error doesn't equal nil. That if you just forget one time, your entire program will panic. So, look, Rust programs can still have logical errors. Don't I know? I've made a bunch of them myself, right? However, you're not making, problems that make your program crash or panic. Yes.
I love the idea of investing guardrails instead of discipline. It does come with some overhead, though.
Yes.
How would you approach an engineer that's used to JavaScript, who doesn't have any meaningful experience with like a compiled language, and educate them for when it's in their best interest to maybe look into Rust as an alternative language? And maybe not for everything, but here are some things that you really want to use Rust for.
Yeah. Well, I'm always of the opinion that using a super structured compiled language with a built-in scaffolding that forces you to code in a very responsible way is the best way to become a good programmer. The compiler is oftentimes a good teacher, right? When I was a kid, I'm young enough that a lot of people my age were just learning Python, Ruby, JavaScript, right? I was lucky enough in that I decided to learn Java or C#, and people were like, oh, those are so complicated. They make you go through the super OOP. But what I really think it taught me was a lot of discipline in terms of setting up formally structured programs with proper inheritance patterns and polymorphism, and proper generics, and dry, don't repeat yourself code. So then when I did go to Python, right, Python doesn't enforce those types of design patterns, but it definitely provides capabilities to do it. So I wrote my Python code in a similar way to that, and I found that I was able to write much more extensible code. So I would say if you're a JavaScript person, especially who's not used to it, you should just take the plunge immediately. Do Rust. It'll train you to do the right thing. Then when you go back and write JavaScript again, the JavaScript code you write will be much more, even though the compiler won't provide the same level of guarantees, you'll be in the habit of coding in a much more defensive way. Yes?
You talk about a circular data structure. Can you give an example?
Of a circular data structure? I'm trying to think about maybe a, Yeah, like a link, yeah, a circularly linked list. It's just where like you have like if you have an indirect, right? So first of all, like if you have like you have to allocate these onto heaps since like a stack can't have like a like a self-referential data structure. But if you have a node that has an optional like child node and it can be arbitrarily deep, there's nothing preventing you per se from having there's nothing preventing you from having a um, like node A that has a child of node B, which has a child of node C, which has a child of node A, right? Now it's a circle, right? The problem with when you get to that is you're doing these usually through what are called reference counters or atomic reference counters, depending on whether you need them to be thread safe or not. If you just use a regular reference counter, it's a zero cost abstraction, whereas atomic reference counters have a little bit of synchronization overhead. But the idea, right, is that it needs to like as you allocate and deallocate, it will drop the strong reference count of these nodes as they get freed, right? But because and then once the reference count reaches zero, it'll actually deallocate. Like when the owned lexical scope goes out of scope, it decrements the reference count, and when it reaches zero, it actually deallocates the object from the memory, right? But because if you have a circularly linked, self-referential data structure, it never gets to that like zero reference count, right? And so if you're not able to properly like deallocate things manually, I think like you can call this method drop, and calling drop will actually erase something from the memory. Now, you might think like, oh, drop is dangerous because what if you try to reference it after drop? Well, drop, like any function, takes ownership. So if you try to reference it after drop, you'll get a compiler error. But you have to do that. So if you forget, that's like one area where you'll have a memory leak in Rust. But to be fair, garbage collected languages are not, immune to memory leaks either. Yes.
I actually have two questions. One's a JavaScript question, one's a Python question.
Okay.
Which one do you want first?
I'll eat my vegetables and take the JavaScript one.
It's not that bad. The Java.
It was written in a week. Rust took 10.
Ever since.
I don't know, one step forward, two steps back. But Rust took 10 years to get perfected. But or a little less. But yeah, go ahead.
Well, if you're already in a JavaScript environment,
Yeah.
that's that you inherited, and you have no other choice except to rip everything out and do it all in Rust, then is something like TypeScript or other things, are you able to kind of like reproduce this sort of programming paradigm like you could in Python, for example? Could you do that in JavaScript environment too, using various tools or no?
Yeah, I mean, you're never going to get the same level. Like the compiler for Rust is incredibly powerful, and porting that over to another language would take a really, really long time. Also, much to my own frustration, like the compiler in Rust is also incredibly slow. Like when I save a file, it probably takes 15 to 20 seconds in my code base for like the red squiggly lines to disappear or for new ones to appear. It's a huge pain in the ass. It's one area that they really need to invest in more. Just all the monomorphization they do with generics, all the ownership DAG resolutions and borrow checkers that they have. It takes a lot of juice to do. And my code base is not that big. It's been about 6 weeks to develop it, and it's only around 30,000 lines, right? But that being so you don't have that super slow but super powerful compiler. However, yeah, absolutely, you can take algebraic data types. One thing about TypeScript that's really good about it is it has a very, very good type system. I would say actually it even has the edge on Rust in that regard. And part of the reason is I forget his name, but a man who is one of the most brilliant legendary program designers designed TypeScript. He originally at Microsoft worked on J++, which was a copy of Java. Microsoft later renamed it to the language we all know as C#. So yeah. Absolutely. In our code base, actually, we do have result that can return, that can either be which is a union type of error and okay, that, we use within our own code base. So yeah, absolutely. But if somebody isn't onboarded to that, they can just like take the results and like they can just call a function and like if they don't if they forget to process the return type, something can return an error, and and if you're not looking at the return type, the code will just proceed as normal. So that's not great. But yeah.
My Python question. Oh, so I go. So you said that I saw that Python, even though it was one of the most popular languages, it was near the bottom of every list on the three lists. So performance, memory, and the third thing, yeah, that one.
Yeah.
So is there any way that we can improve this? You're saying they could reproduce this sort of paradigm with different tools that Python now has. Like, is that going to allow us to improve the time for the memory on Python specifically?
I don't understand why Python is like this. I mean, first of all, like it seems that the creator of it, Guido van Rossum, is a dick. Pardon my French. I know this one girl that when she worked at Dropbox, she walked past him in the hallway and she said, "Oh, Guido, can I take a picture?" And he goes, "No." Anyway, though, when we take a language where the time library, which came out in Python 1, says Sunday represents a 0 ordinal, and then the datetime library, which came out in Python 2, Monday is the 0 date ordinal, you can only expect so much from it. Python's approach to solving problems is to like not worry about them. Essentially, I'll illustrate two examples. One, they solve like concurrency issues by introducing the global interpreter lock, which just means that concurrency isn't allowed. And then there was this one really hairy issue with MyPy, an ability to like introduce statically analyzable types to Python at compile time, or at lint time, whatever. And and instead of resolving and letting my friend merge this PR in that would have resolved it, Guido said, but the runtime will be able to figure it out, which is just like, well, the raison d'etre for MyPy. So I don't really have an answer for why Python is so slow or so bad. I would imagine that Python is just a language where everything is resolved at runtime. It's interpreted, right? And so like it's just when you have everything is when everything when everything is introspective, and everything is resolved at runtime and everything is metaprogramming, like those types of languages are just like kind of like those like macro at runtime languages are always just going to be slow. Another example is Clojure, right, which is a great language. My friend Warren codes in it all the time. It's basically C Lisp for the JVM, but it is very macro. It's very magical, and as a result, it's very very slow and memory intensive.
It would be near the bottom.
Yeah. Anyway.
On there.
Yeah. Somewhere down here. Okay.
One question is like every Rust programmer I've spoken to, there's always like Rust rewrites your brain a little bit.
Yeah.
Where like unlike most languages, like you're saying with Python and JavaScript, you're used to saying like yes, 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 and like moving forward, and then if you get an error, you have to resolve it yourself. But then Rust takes that opposite approach of saying you no, no, no.
Yes.
And then you need to just have this conversation with the compiler about like lifetimes and ownership, as you're describing, and more. How did you reason about that coming from like Go and Python, these other languages, and rewriting your brain? What was your experience, I guess, through that whole conversation with the compiler? Like, how did you? How do I want to describe this question? Like, yeah, how did it rewrite your brain? How did you get accustomed to it? Did you read? I know you read like the Rust book.
I read the Rust book. I'm not a fan of using AI coding or vibe coding or anything like that. Not that AI is particularly good at reasoning about the biochecker lifetimes anyway, but I do find talking to ChatGPT about my programs is very good. Sometimes ChatGPT isn't right, and sometimes it'll have wrong answers, and I'll have to say yes or no, but it's always a really interesting dialogue, right? It's like having Alex by my side all the time when he's not, but Alex would rather, but Alex would rather hang out with his wife than myself, which can't really blame him. So ChatGPT is the next best option, and I think overall, yeah, it's a very difficult model to program in, especially like right now. I'm about to go back to work and I'm running up against a huge deadline, and I'm just can't be like, that's a problem for tomorrow, right? Like it's like, no, like it's a problem I need to deal with now, right? But these types of things are actually the right way to reason about any program, right? Like ownership is not like actually like the idea that a function owns a variable now and you shouldn't be able to modify it outside of that function is ultimately the correct way to model a good computer program. It's just not something that's necessary 70 to 80% of the time. But I think a lot of times what Rust is enforcing is good programming design, even if it's not strictly necessary. You know, honestly, it's not, there's no magical silver bullet, right? Like I'm a big believer that there isn't an easy way out of things. And by trying to to find the easy way out, you're going to be, you're going to hit difficulty. So it's better to actually choose something that forces you to be rigorous.
Amazing, thank you.
Yeah.
And you kind of talked to me about we talked a little bit about this before, but my question is actually very similar to Alex's, where you mentioned that Rust, you found the compiler to be a great teacher.
Yes.
And so, my question is, what was some of those things that you learned from interacting with the compiler in this situation that really opened your mind and taught you some new things? What were some of those big items that you learned that you would be able to bring back to, say, TypeScript or something like that?
Yeah, I would just say, be careful, be careful with what you share. Keep everything on the stack. The heap is your enemy. If you need the heap to use the heap, you can, but you shouldn't. Because the heap is where race conditions happen. It's where overhead happens. It's where memory leaks happen. The heap is the evil, dangerous place, and the stack is where things are secure, right? So keep things on the stack. Be careful what you share. Be careful what mutates and what doesn't mutate, when, where, and why. Make things immutable as often as possible. And generally speaking, represent things as failable unless you know they aren't.
Thank you.
Yeah.
Any more questions?
Thank you.